recorder. And it is recording, so it's all good. All right. Excellent. So did you guys have a chance to play with App Inventor over the weekend? A little bit? Cool. All right. Are there any questions as you played with App Inventor? Are there any questions? Yes?
In Moodle, the lessons that we have, were those created with the old classic App Inventor?
Some are, but most are not. Okay. Most, will give you an AIA file, which is from the new App Inventor.
I'm talking about the directions and the pictures, the images that are included in the lesson.
Some maybe, yeah. Some are really, really old.
Just for like class knowledge, like web access is, and it's a little bit hard to get through it.
Oh, okay. I see. All right. Well, thank you for that point. I will make some changes, when I have time. Any other issues? Yep.
I tried to I tried to install it on Linux, but I have a 64
bit machine.
Yeah, machine, and it said you need a 32 rather than a 32. On the instructions, it said the App Inventor only installs on the 32 system.
Oh, okay.
And anyways, I tried to get the 32 file.
Right.
Said, but
it will not install?
I could not work that thing.
Okay.
Because there you can download it from the GitHub, and as long as you can get like Apache running with Ant and Java running, Java 7, then you can just run a local instance on your machine.
Well, that may be a little bit too much for the scope of this class.
I have a Windows system, so I put it on Windows.
Yeah,
so it's much easier.
Yeah, the key is just to get it to work. Yep. All right. So what we'll do today is we are done. Well, not done, but this homework assignment was assigned last week. I think many of you got it done, turned it in already. So you guys are okay, done with that one, and we're going to start with something new this week. Yep, go ahead.
And it's due Wednesday. Right?
It is due on Wednesday, correct? Yep. Okay, so what we'll do today, and for the most part, this week probably. Okay, do you guys have any questions back there? Yep. Any questions? Anything I should know? Okay, all right. Thank you. So what I'm going to do is to start with something that we talked about on the other day, which is, should you jump into programming like as soon as you get an idea, like, oh, I think this would be cool to do something like this. Should you jump in and start coding right away, even if you can, okay? Some people in this class, I'm not going to point out, but I know some people in this class, okay. Back there, no drinks, please. Plain water is fine, but anything that's sugary, probably not in class. Okay, that's okay. I just wanted to remind you of that. Okay, but why shouldn't we jump into programming like as soon as you have an idea of, oh, this would be cool, I want to do this. Okay. Any idea why? Last time I used the example of you are given, okay, the property on Highway 1. Yep.
If you think of something later on in the project that you want to add in, you have to redo most of what you already did.
Exactly. So in the analogy of building a house along Highway 1 next to the ocean, really nice property, you build a house already, but without thinking it through, and then you realize, you know what? I want my bedroom to be on the second floor, but it's a single-story building. So what do you have to do at that point?
Tear it down.
Or massive remodeling. Okay, sometimes remodeling in that scale is more expensive than tearing down the whole thing and then build it again. And you might think, oh, but this is really just silly. But this is an extreme case of not planning and build a house and stuff like that. But guess what? Writing an app is the same way. Okay, if you don't lay down the foundation, so it's ready to build like a 2-story or 3-story house in terms of software, you can build something real quick, single story, with a roof over it. It's easy. But as soon as you try to build anything on top of that, then you start to run into problems. Okay, it becomes very tedious or just nearly impossible to do things. Okay, so you have to kind of think ahead of time and say, okay, what is your vision of the finished product, what it is supposed to do, and so on. So this slide is basically just outlining why you should not jump into programming in the first place. In computer science or ICT, people call it ICT these days, which stands for Information and Communication Technology, which is basically just computer technology stuff. There's a field called systems analysis. Okay, if you right-click on this link here, it brings you to a Wikipedia page on systems analysis. So what we'll do is we'll just read this paragraph here. I don't want to bore you with the entire everything about systems analysis. Is the process of studying a procedure or business in order to identify its, okay, so these are the keywords here, its goals and purposes, and create systems, which includes big systems, small systems, apps, server-side software, and procedures that will achieve them in an efficient way. Okay, so what I do want to do here is to identify or to point out the important parts here, okay? The goals and the purposes, objectives of something. Why is that important?
It determines the procedures, doesn't
It's like, a destination, right? Yeah, go ahead. Okay, if you think about software development, like driving, okay? How many people drove today to campus, drop off the kids? How about bikes, walking, any type of mode of transportation? Okay, some of you did not raise a hand at all, so I'm going to assume teleportation, which is a form of transportation, okay? So, when you're driving, you need to have what in your mind? A destination, very good. Okay, you need to know where you are going in your mind, okay? Now, sometimes when I drive my little car, I really drive it without a sense of, destination, and that's the whole point of that type of driving. But for the most part, okay, for the rest of us, we like to drive with a certain destination, okay? Now, that is important because with a destination in mind, what if the road that you usually go through is under construction and there are signs that says, okay, go this way, there's a detour. That won't throw you off completely because you know exactly where you need to end up at. So you just find a detour, find another route to get to the destination. That is the same way with software development. So once you identify the goals and purposes of a particular program, which can be an app, if you encounter difficulties, it's not going to stop you from getting to the destination. It might take you longer, okay? You might need to do a few things to get to the destination, but you will still end up at the destination. But on the other hand, if you do not have the goals and purposes clearly identified and stated when you start the software development process, you can end up with what we call feature creep, okay? So let's take a look at the word feature creep. And feature creep is the ongoing expansion or addition of new features in a product. In our case, we are concerned with apps, such as in computer software. These extra features go beyond or maybe unrelated to the basic function of the product and can result in software bloat and overcomplication rather than simple design. In many cases, feature creep is also one of the leading causes of not being on schedule. Okay, so think about this a little bit. So let's say you are going to you're excited and you want to write an app to do a particular thing, and I'm going to give you an example: a golf app they want to do so that people who play golf can enjoy the game and let other people share their experience because they think that this is so fun. I think everybody should at least know what I'm doing. Okay. And then somewhere along the line, you go like, hey, I want to put a feature in this app so that people can shop for golfing equipment while they're golfing. Not an unreasonable kind of thing because you look at all the other people who are competing, who are outdoing you, and go like, what kind of club do they use to beat me like that? Okay, you go like, okay, I'm gonna buy that or buy something better so I can top these people. So not unreasonable. But once you get into shopping, then you go like, hey, maybe these people are bored, halfway through the game, So maybe I'll just let them shop in general. Now that's a feature creep, because it has nothing to do with what the app was supposed to do in the first place. But you can see how it can like gradually move out of the original identified objective of the app. Is that making any sense? Okay. Yep.
How does that work though with Agile and the rapid development cycles of Agile?
With Agile, okay, the concept of Agile is to contrast with the usual, what we call a waterfall type of model. So, to understand, you can say, okay, you can look up Agile versus Waterfall, because those are the two contrasting models of how you develop software. So Waterfall is a name that basically says, okay, you have to do everything step by step. Okay, it's like building a house. Okay, it's usually still using a waterfall model. Yep, go ahead.
Sorry, this is just something that the way I understood it based on the work experience I've had. Basically, in agile development, it's not that you don't plan; it's that you plan smaller things. It's not that you're not doing any planning. You are doing planning. You just have like a smaller set of objectives each week when you're doing your Scrum, and so you should still be like focusing on getting your design document and all of your specifications in order before you start coding, because that's like I said before, every function should be entirely obvious.
Okay.
To write.
That's a really good description. It's in smaller steps, and you break the whole process into instead of using a non-repetitive process, and you only go in one direction, and you don't proceed to the next step until you are 100% done with the previous step. You use a more repetitive type of cycle and say, okay, we'll do the entire cycle, but only for this part of the project. Then we'll do the entire cycle for this part of the project, and you're not married to any specification. You feel free to change some of that stuff and then redesign and redo stuff. I'll give you one example that should kind of give you a picture of what one looks like and the other one looks like. Okay, so the waterfall model is kind of like you have a huge washing machine and a huge dryer, and you say, I'm not going to start the washer until I have enough laundry to fill it up. Okay, so what you do is you wait and you wait and you wait until you have a full load. And obviously, unless you run your washer, there won't be anything to dry. So your entire dryer is also empty for the most part until you are done with your washing. But you are never going back and say, oh, I think I need to wash some more. No, we got to wait for the next cycle, next month. That's the waterfall model. The agile model is more like you have a smaller washing machine, and you're just kind of flexible. It's like, oh, okay, there's too much stuff to wash. You prioritize. Okay, what do I need immediately? The next day, the next 2 days, we'll wash that first. Okay, and the rest, it's not something that I need right away. We'll just wait a little bit. Okay, and then when you have time, and it's just there's nothing using the washer, then you start to empty the other stuff where they may not be needed right away. So you prioritize. You use a repetitive cycle to get things done. Is that okay? I mean,
so you avoid feature creep by prioritizing.
You still have to keep your objective and purposes really, really clear. So that part is common to both development models. You still need to clearly identify and keep in mind what the system is trying to achieve in the end. Okay. It's just that in the implementation, one says, you cannot start the next phase until you're completely done with this phase. Building a house, there's no choice. You have to use the waterfall model, except for decoration stuff where you can kind of use the more repetitive, type of thing. Yep.
The way that Agile builds in kind of protections to feature creep is that at each step you should have a functional product. So the common example is that to build a car in Waterfall, you would put it on the wheels, you would put on the everything else. To build a car in Agile, you might start by building a skateboard, and then modify it to make a bike, and then make it a car. So That way, you at least have the mitigating factor that even if you have this feature creep going on, then you have a functional product. And you also generally like ask your clients to kind of give you feedback in order at each step in order to kind of go in the correct directions that your clients want.
In other words, one is more interactive. Agile is basically interactive, whereas the Waterfall is non-interactive. You only go in one direction until you're ready. You do not move on. Whereas the other one is like, okay, these are all important features. We'll get these done first. Okay, serve. The program or the system will start to serve its purposes, even though it may not be the entire set. It will become functional. After the first cycle. And then you prioritize and go, okay, what do we want to introduce in the next release? Okay, prioritize, these things are the next things that we feel are important, throw those in, and so on. Instead of implementing everything first before you release the product.
What if there's an underlying architecture that needs to be done? Is that
There's a vision of
Okay.
what the entire thing should look like in the end,
Okay.
but you are only completing it in phases. And you cannot build houses like that, really, because with a house, you cannot just say, I'm going to lay the foundation of one part of the house and build a part of the house so people can move in first, and then we'll finish the rest later. Because the roof is one single piece, you cannot just say, oh, we'll just do one piece at a time. Now, there might come a time when we start to have modular buildings where you can just plug in like Legos. You can just say, I want another room. You just buy another room, plug it in, and it's all done. Okay, but at this point, we don't have that type of construction technology, so we can only still do just waterfall model when it comes to building houses. Now, to put things in perspective, in software development, there was a time when waterfall is the only way to do things. Okay. So we have to kind of think back in time what mainframes look like and how people would develop software on mainframe computers. Okay. Does anyone have any exposure to mainframe computers? What they look like? How do you program those things? How do you interact with mainframe computers? We are talking about maybe in the 60s. Okay, so just to give you a time frame. First of all, you guys are so used to your mobile devices, right? Okay, so I'm gonna throw mine out here and say, okay, this is very interactive, right? You can do stuff and you instantly get a response. Okay, you do a Google search, you instantly get a response. You text somebody, you instantly get a message sent. That is not the case with mainframe computers. With mainframe computers, how do you write programs to run on the mainframe computers? Okay, I'll give you a few options here. So, in today's term, okay, if I use this method and just use a text editor to write my programs, it's already considered archaic, right? But at least one, I have a full screen editor where I have cursor control to go between the lines, and I can do most of the text editing fairly conveniently. Okay, it's not GUI. I can do this in complete text mode. It's archaic. It doesn't look fancy at all, but it can get the job done. There was a time when full screen editors was not available, and they had what we call line editors. You can only edit one line at a time. Okay, and then and that's because of the input-output equipment. Now, this is a full screen, two-dimensional device. I have a full keyboard, so it's easy for me to move up and down the lines and make any changes on any line. What if your user interface looks like a typewriter? Or what if it is a typewriter? That is your terminal. So you don't have the ability to do like screen editing. You can only say, oh, I think I need to edit line 200, list line 200, show me what it is. Okay, that's the right line. And then you can say, okay, this is what the line looks like at this point, and you just type how you want to change it on the typewriter. Okay? What about before that? What do you think a user interface looks like? Because typewriting or TTY, teletype interface, is already considered a breakthrough compared to what people had to do before that.
punch card?
Punch cards. All right, very good. So what do you think punch cards look like? I know you guys just say, I don't want to know. That's okay. I want to know, and I'm going to look for it. Okay, so you look for punch cards and go to images, and this is what punch cards look like. Okay, and this is, so basically for each line, okay, you have to indicate what you want to be on that line. So one card is only good for one line. One card is only good for one line of code, and you need to punch out the proper notches and stuff like that. So how long do you think it will take to write a program?
Long time.
Pretty long, right? Because what if you make a mistake? Do you get syntax highlighting with a squiggly red line under that and say, hey, you might want to reconsider this thing here? No. When do you know? Okay, oh, by the way, what do you do with these punch cards? Oh, I'm just going to use my cell phone, turn on the camera, and just take a picture and send it to the server, right? Because that's what most people think these days. I'm just going to take a picture, send, share, done. No. What you do is you get this thing done physically, you end up with a big pile of punch cards. And then what do? You go to the server room where there'll be a boring person at a counter and say, okay, your job is scheduled at 6 a.m. in the morning, come back for the results at maybe noontime, the next day, right? Or the day after that, depending on how busy the server is. So you won't even know that you mispunched one notch until like a day later. Because they'll just give you the output of whatever your program specifies, which can be just completely bogus stuff, right? So you have to look at the output of the program on paper and figure out what's wrong with your program, fix it, and then repeat the whole cycle. Now, given that is the context, Agile is not an option. You better plan things out really, really well before you get to the punch card phase, because the cost of changing is really expensive. Does that make any sense? So it's not like people in those days are not smart and they can never think of good stuff that we have today. It's because they did not have the technology. It was not even possible. Okay, all right. So given that is the context, but it still applies today. Even though we have really convenient tools, having an idea of what the program or the app is supposed to do and keep that in your mind all the time is important, okay? But I like the introduction of the Agile concept because it means, basically, it also makes it easier for you to market your app. Now, this is important to all of you, okay? Because we're not talking about history, we're talking about how you can leverage Agile development methodology to help you release your product early, okay? So let's say you have a vision of something that nobody has done before, okay? And it's a really important thing and you want to get to the market as soon as possible. So you have a vision of what a finished product should look like, a lot of features, really good, useful, complete, looks good and stuff like that. But to get to the market first, what you want to do is to select a core set of features, get it implemented, and not necessarily have a really clean and good-looking interface, just get it out to the market first. Okay? While your app is already in the market and people download it for beta testing or for like next to nothing or free, you are working on the next version already. So by the time your competitor is copying your software and have their own version up, you are ready for the next release with more features. And you keep yourself one step ahead of your competition doing this. Instead of waiting and waiting and waiting, like 2 years later you have the product out, other people would have beaten you already to the market. This way you get to the market first and just say, this product may not have everything that I want in it, but it has enough so that people would actually download and use it. Okay? Prime example, Pokemon Go. It still has bugs. Now that it is quote-unquote dying, it's still not fixed. Okay, the developer just did not fix the product at all. I mean, the bugs are still there. You still have to shut it down and restart it constantly, because it just cannot keep track of multiple things at the same time. And another example would be a big corporation that starts with M. All right, so this is a lot of boring stuff. If so, you want to read it, but I want to just kind of talk about it. So what I consider as a value is the why of somebody. It's not to you, okay? Remember, when you look at these things, it is not from your perspective as a developer. It's not like, I feel it is going to be cool to have this in this program. The question is, are the end users going to look at this as a useful feature, okay? So a value is basically a reason for somebody to download and install your app. And usually in the context of instead of somebody else's. Okay, that's a value of an app. So I'm not going to bore you with just reading through all this stuff here. And I'll just give you an example down here. The value of a passenger car, now this is not the Blue Book value, that sort of thing. This is the value in the context of purposes. Okay, so the value of a passenger car or truck or something like that is the ability to go from one place to another place. Transportation, that's the value of a car. So ultimately, that is the reason why somebody wants to have a car. Okay. Now, obviously, to some people, it's also a status of symbol of status. Okay, I drive a Mercedes or some other expensive German cars or whatever. Okay, but to most people, it's really just I just want to go from point A to point B. I need a car. Okay. So in the case of apps, I will give you an example of a word processor. So what is the value of a word processor? Okay. Now I want to emphasize the value of a word processor has nothing to do with its features. Okay. So boldface is not a value. Italic is not a value. Save is not a value. Searching in a document is not a value. The value is the efficiency, improved efficiency of writing and maintaining documents. That is the value of a word processing app or word processing software. Or these days it is cloud-based. It's like Google. In Google Documents, it's called
Drive.
No.
Drive.
But inside Drive, there's a name for that app. Right? Is it Google?
Huh?
Google Docs.
Google Docs, just Google Docs. Okay. So Google Docs is the same way. Okay. It is just a way so that people can write, create, maintain their documents with efficiency. And a lot of times, the value of an app or the value of a particular program is relative. So you basically want to compare a word processor on a computer as opposed to handwriting or using a typewriter. Okay, so that is the value. But what about all that boldface stuff, all the icons, all the menus, all the shortcut keys and gestures and whatnot? That's how it's done. Yeah, it has nothing to do with the value of the software. Okay. In other words, the value of a word processor does not change when computers become telepathic. You think, and it creates a document for you. It's still a word processor, except the interface has changed. You don't use shortcut keys. You don't use icons. It's just it can read what I'm thinking and type the document automatically. Okay. So there has to be a reason for why an app is installed. So if you look at your phone, okay, go through the apps that is already installed, and you say, okay, why did I have this icon here? Oh, right, I needed that to shop at Amazon. Okay, why did I have that icon over there? Oh, right, I need to track the sun movement for gardening purposes. Okay, with the exception of T-Mobile apps, where it's pre-installed and close to impossible to get rid of. Okay, so those are exceptions to the rule because the carrier wants to just load up their phone with their apps. There are ways to get rid of those too, but I'm not going to talk about it in this class. You guys have to look it up online. What about a banking app? Okay, I'm pretty sure many of you bank online. Okay, back in when you're using computers, but these days it's even more convenient using a mobile device. because a mobile device is with you all the time. Okay, you don't have to go home so I can get to the computer and then do some online banking. You just take out your phone. Okay, a few swipes later, you can transfer money, you can cash checks, you can check on your account, and so on and so forth. Okay, but what is the value? Those are the things that you do with your banking app. But what is the value of a banking app? What are the reasons why you install a banking app? Is the
Convenience.
Is the convenience of having access to your bank account without having to go there, or to do it over the phone. You just have constant, 24/7 access to your banking resources. It's the convenience. Okay, so you have to look at that. And once again, you're comparing the app with the alternative. The alternative is physically going to a particular branch of a bank and wait for the bank to open. Or to use an ATM, and you have to drive and stuff like that, right? So it's always comparing to something else. Now what is interesting, this part is new. If you have read this slide before, this part is new. Games is an interesting category when it comes to the value or the purpose of the app. Because when you look at any game, what is the value of any game? Just pick any game.
Entertainment.
For entertainment, very good. So there really doesn't seem to be a whole lot to say about games, and it's really general and it's really vague. It's just for entertainment purposes. So that's on the surface. But if you just use that as a guiding principle for your game app, that's not going to be very helpful, because you need something a little bit more specific. Because in other words, if you just say, oh, I'm going to write a game because I want the end users to be entertained by this app, okay? That's kind of like specifying your destination as, I just want to go to San Francisco. But where in San Francisco? I don't know, I just want to go to San Francisco, right? It's not that helpful. It is helpful in a way, but not really that helpful. So you want to be able to refine your objective a little bit more. And this is where I did some research last night and found a few resources that you might find helpful, okay? So games actually satisfy, some games are catered to the adventure-seeking crowd, okay? You get to experience new things, new virtual worlds, explore stuff and whatnot. Some games, satisfy the tactical-oriented people because you get to shoot stuff, right? You have to dodge, you have to shoot, and then you can level up and get new weapons and stuff like that. And then some other games appeal to the intellectual crowd, where you have to kind of solve problems, okay? Tough problems to solve. Everything is a puzzle, and you have to solve. Now there are cross-genre type of games where it's technical and intellectual. Portal is one of those games. How many people have played Portal? Okay, so do you think it has both the kind of tactical side where you have to do things in a certain way, but it also has the intellectual part because you have to find out how to open the portals in sequence to get certain things done, right? Does Portal have an app version?
Probably.
That would be awesome if it has an AR version. And somebody decides to map out buildings, shopping malls and stuff like that, and you just play your AR version of Portal, and it just says, okay, you're in Sears right now, you need to go to Macy's, and in between there are robots that are trying to kill you.
Sure.
What?
But we don't have, that wouldn't really work that well because we don't have a portal gun in real life.
Yeah, you just have to walk there.
Yeah.
You have to be like,
We
all right, you
haven't
made
had
it.
though.
But
You
you
have
have
a-
a mobile device that has all types of sensors and can do all types
Exactly.
of
They
things.
can't teleport you though.
They cannot actually tell.
teleport.
You can teleport you in AR or in some other.
Well, if the
you
software
were
has a full
playing VR.
3D model of whatever structure you're in, then it's not AR anymore. It will become just VR. But it's kind of fun. I mean, if you're in Maze, if you're in Arden Fair Mall, you just started the game and you're playing Portal with Arden Fair Mall as the actual structure. Yep. So here's $1 million idea. You guys just have to pursue it.
I think it might be copyright though.
But don't call it Portal. call it doors.
Wormhole.
Doors. Openings. All right. Okay, so I located some, articles and publications. This is one. Okay, this is just one here. It talks about, how video games actually help satisfy basic needs, and that's what, that's why people are addicted to games. That's why people say, "Oh, I want to download this game," but they cannot get out of a game because it is satisfying some of the basic needs to the point where, hey, I just need the game. I don't need anything else. Okay. So you might want to read this if you're interested in game development, or if you're interested in how we can define the value of video games. Okay, because it's not just entertainment. You can now tie it to some specific basic needs. Okay, so there we have autonomy. Feelings of autonomy is a big one. Competence and relatedness. Okay, which is basically, I guess, relating to other people. So these are really common threads of all popular games. Okay, I look at my kids, I don't play a whole lot of games anymore because I don't have time. I have to grade your homework assignments and stuff like that. But if you look at most video games, it has a sense of autonomy. What is the sense of autonomy? What does that mean? You can do stuff, right? So most games give you the freedom to do a lot of things. There's a lot of degree of freedom in the world, in the game world itself. You can go to places. You can choose how to interact with other characters, and so on and so forth. So that's autonomy. Because in real world, you don't get as much autonomy. Okay, driving games. Okay, has a big portion of autonomy, a feeling of autonomy. Even if you have a car that can go 300 miles per hour, where are you going to drive that car at 300 miles per hour?
And crash and live.
And crash and live and just go, I'm just going to restart the game. Right? Okay, that's autonomy right there. Okay, things that you want to do but you cannot do in real life, hey, in the game, you can do that. The feeling of competence. Now, this is a big one. Okay, I observed what kind of games my kids like to play and what they talk about after they play a good game. It's a sense of competence. It's a sense of, I got a higher score than those people. Okay, I got a score that is better than my score yesterday, or I level up. Pokemon Go. Okay, how many people play Pokemon Go, or at least know what the game is about? Okay, so what kind of competence? What conveys competence in that game?
Catching them all.
Catching them all. Okay, you can look at your Pokédex and it gets filled up, right? Okay.
Fighting other teams.
Fighting other teams and winning. Okay. Yep.
Competitiveness.
There's the competitiveness. Yep. Mm-hmm. You don't have to be competitive because you can level up just by collecting stuff, right? But you can look at your backpack filling up, right? Okay, maybe it's just filling with potions, which is next to worthless, right? But it's filling up. Okay, you look at that number. It's how many items out of 350? Oh, I'm filling up my backpack. I'm feeling good. You can look at your level, right? You can look at your XP and say, I'm about to level up. Oh, I'm level 20 now. Yes. Yep.
Do you think that's why they put, in Pokemon specifically, they put in those little achievement awards that pop up and you gotta like...
Oh, yeah. Yeah,
Is that the fulfillment of that?
The badges is a really, a lot of stuff now has badges. We are going to transition to Canvas as a learning management system, and Canvas is big on badges. Okay, because it's like a reward thing to people, so they may have a badge for who is the first to post something on a thread. You get a badge. Who has, who is exceeding 500 posts, in a particular forum, you get a badge. Yep.
This psychologist, B.F. Skinner, very influential psychologist, who came up with the theory of behaviorism, did an experiment with a bunch of rats, and he had like levers. In one of the levers, it was just a control, it did nothing. In one of the boxes, the lever constantly popped out food. But in the third one, it sometimes like popped out food and sometimes gave a shock. Oh, sorry, the first one I think it gave a shock too, and it turns out that the rats who had the first lever, they stayed away because they don't want to get shocked. But the rats who got food from the lever eventually got bored of it. But the third ones who got food most of the time got shocked
crazy.
some of
They went
the time.
crazy, right?
Yeah. So that's kind of ties into the whole achievement thing. It's the Skinner box. It's basically saying, okay, we're gonna give you this for something that you do. So you just get a random reward, and that goes and causes people to want to keep playing.
Yep, it's not deterministic. Things
Yeah.
are not deterministic, and that's one big thing about Pokemon Go too. Okay, so you look at so let's say you're level 15. You look at a 300 CP Pokemon in the wild, and you only have red balls. Okay, what are the chances you can catch that in one throw? Well, there's a chance, right? But it's probabilistic, and that's what get people hooked. Because if they just say flat out and say red ball sucks, cannot catch these high CP Pokemon, people would just stop playing. Or you can just give them ultra balls all the time and say you will catch it every single time. People will stop because of boredom. You have to say, oh, with a red ball, you get about 45% of a chance to catch that. People will just keep throwing red balls to the Pokemon. And that's the nature of games. Okay, it is a part of it has to be non-deterministic, where people have a sense of, oh, I don't know really exactly what's going to happen. I know what good things can happen, so I'm gonna try. I will keep trying until that happens. I look at my wife playing Pokemon Go, and that's exactly what happens. 20 balls later, oh, where's that Pidgey? Oh, it just ran away. And I kept trying to tell her, try a curveball. And she cannot do the curveball thing. And I keep trying to teach her, okay, wait until the circle is small, and then try to center the throw. Then you get the extra 100 XP just for a great throw, and then 10 more for a curveball. Then for every Pokemon, you get 210 XP instead of 100 XP. No, the math is not working. But she really likes to play that game. And a lot of these psychology doesn't work only on kids. Adults are the same way. So keep that in mind if you are writing a game app. Okay, so you want to kind of dial into specific things that draw people to install and play your games, and not just quote unquote entertainment. Okay, you try to make it a little bit more specific. Now, I also want to mention that features are not values. Okay, features is kind of like what makes it work. Okay, it's kind of more mechanical. I'll give you an example. Transportation, trying to go from point A to point B, is what you want to accomplish. Okay, and the feature is automatic transmission. Okay. Well, do you need automatic transmission when you have teleportation? Do you care about automatic transmission when you have self-driving cars? Exactly. So a lot of the features are really implementation details that you really should not need to put a whole lot of focus on when you just think about why do people want to install this app. Okay, just think of reasons but not features or how things are done. Are we still doing okay so far at this point? I know all this description has nothing to do with or nothing specific to app development because it's universal to any type of program. Okay. So the value is basically the guiding principle of your app, and it helps to reduce feature creep. Now, feature creep is bad in many, many ways because you can end up wasting your resources and delay the release of your product. Okay, that's the bottom line of why feature creep can be a bad thing. It's just like if you're Honda and you're trying to make a new car or improve a car for the next year's release. So with Honda, they have a very set schedule of every X number of years they will come up with a brand new model, not just a reface of the previous year. And with that in mind, feature creep is a big no-no because you cannot just say, oh, we're not quite done yet, okay? Because we're still working on, some feature that is not core to the function of a car. Is that okay? Kind of like a deodorizing ashtray. Don't let it stop you from releasing, the model year, the next model year. Okay? If you get new transmission, new engine already done, new suspension that is already done, or the core features that sets this model year to be really a lot better than the previous year, if you cannot get the deodorizing ashtray, don't bother because most people don't use it anyway. Most people just go like, just get it out of the window, so they don't need an ashtray anymore.
It's like navigation. Get rid of that. People just use their phone.
I have not seen a feature where you can project the Google navigation screen on your phone onto your car's LCD display. Now that would be a really cool feature.
Yeah.
Yep.
Another one to go right along with that. Why isn't there Wi-Fi for your vehicle so you make your vehicle a hotspot?
They do have
Yeah,
those.
that's like wondering.
That comes from the dealer. From the
Well, it's a
manufacturer?
subscription, you pay, but yeah, it has Wi-Fi built, like, so it just connects to the cell network.
A
They
hotspot.
made a deal with the cell network, and
And
it's
then-
become a hotspot, so anybody in the car can use the hotspot.
Okay.
Okay,
And
go
it's
ahead.
an integrated item, not.
It's an integrated item,
Oh,
yeah.
okay. I
So
didn't
we
know
had
that.
like a few months free, and then
What service does
To
it
get
run
you
on?
folks.
Metro, Sprint?
I actually don't know which service it runs on.
See, that's what I'm talking about. Is like more of the, we pay $60 a month and it Wi-Fi's it.
But,
I mean,
but
there's
more
been-
and more phones now can just project a Wi-Fi too, so you can almost get your service on your phone. And if you have an a la carte service, it's basically
Okay, we
the same
can
thing.
carry on
There-
this for just a little bit more. Okay, go ahead.
There are serious security issues with the implementations of Wi-Fi currently in cars. For example, there was a proof of concept that was done with Jeeps, for example, where hackers could effectively take control of the Jeep, take control of the steering, and there was a good wire. There was like a video too. I think they saw it it was on Last Week Tonight, and it was also on some other places. I think it was like from Wired magazine or whatever. But effectively, they basically took control of this guy's car, who had volunteered for it and not really given too much extra information, but he volunteered for it, and they went and like reduced his speed to near zero in the middle of the freeway, and they were just kind of laughing, and then they like made it back because obviously it was a scary experience, but yeah. So that's the major reason why you should try to avoid these cars which have Wi-Fi in it, because many of them have serious security issues because they're car manufacturers, not technical people.
And that's the other part of feature creep. Now this is a prime example of feature creep because cars are cars, right? Trying to extend the expertise of making cars to securing networking and doing encryption and making sure everything is secure is pushing the car manufacturers beyond what they're really good at. Now, if they kind of like work with Cisco, okay, maybe that's not a bad idea. But do they work with Cisco?
But more and
Maybe,
more, yeah.
probably not, right?
More and more are partnering with other expertise.
Oh, they have to.
They have to because they don't have
Yep,
that expertise.
they have to. There's no choice anymore. A lot of cars, can have your onboard diagnostic (OBD2) interface to be accessed remotely. Now that can be a big, huge, security problem as well. But the technology is moving that way, and car manufacturers really just have to kind of move with it for the most part. They cannot just say, we are not going to do it.
Right.
But they have to do it, especially if the state of California, once they say, all cars must have these particular interfaces, if they specify wireless access to the onboard diagnostic computer, then manufacturers really don't have a choice. They have to do it.
Yeah, I'm part of the pilot program that tracks how far you drive based on that port.
Onboard diagnostic?
Yeah, because they're going to try and change the tax for
Yep.
roads based on that, how far you drive. And so the pilot program does all the communication to that roads and those licenses.
And that's why in Fast and Furious, Vin Diesel is always driving a vintage car. There ain't no stupid computers in my car. There's no hacking unless you use a crowbar. Then I'm just going to punch you out. Yeah, those movies have changed. Those movies have feature creep as well. If you think about it, movies have feature creep as well. So instead of being just driving, a driving movie or car movie, it's now, espionage, spy, and all kinds of other stuff, thrown into it. You can probably see a resemblance of Rambo movies in, what was I just talking about? Fast and Furious. Yep, yeah. Fast and Furious crosses with Rambo.
Godzilla smashes Vin Diesel's car.
Yep. All right. So, from the values which identifies why people want to install your app, at some point you cannot just say up there all the time. So at some point you will have to kind of think about, okay, now that I have identified that the value of this app is X, Y, and Z, then you have to kind of imagine, okay, if somebody actually install the app, how are they going to use the app? Now, that is a very important transition because it goes from a very high-level abstract kind of thing, which are the purposes and the vision of your app, to something that you can actually, say or even mock up, right? You can just say, oh, I think there will be a screen like this, people will click this, and then the next screen is going to look like this, and so on and so forth. You can actually describe, draw pictures about that. Are we doing okay so far with the transition? Okay? All right. So the use cases is basically just that, okay? How is someone going to use your app? So the value is why somebody wants to install the app. A use case is a high-level description of how a value is fulfilled. Okay, example is an online banking app on a mobile device. The value of an app in this kind of app is just convenient banking. Okay, I just want to do all the banking stuff, but without having to wait for the branch to open or have to drive to an ATM. Okay, just want to do everything in the comfort of my home. But how is someone going to use the app? Okay, now that we know what the app is supposed to do, how is someone from the end user's perspective, how to use the app? Okay, so one way that someone may want to use this app is to be able to cash a check, okay, using the app itself. That's one use of the application. We are not talking about, oh, then I have to use the camera and then we have to frame the check and stuff like that. Nope. You just say, we use the app to cash a check. Exactly how it's done, what kind of devices do I need and stuff like that, that's kind of below this level. Okay, let's not think about how to implement that feature, but just to focus on what people can use your app for. Okay, I want to be able to cash a check. Cool. I want to check my balance. No problem. I want to pay my bills. Okay, so those are the things that people would want to use with your banking app. Is that okay so far? But what you also want to pay attention is not to include signing in as a use of the app. The reason why signing in or signing out, for that matter, is not considered as a use case is because by itself, it's useless. In other words, let me ask you this question. Will someone install a banking app just so that that person can sign in to the bank and then do nothing else? Absolutely nothing. Well, maybe to a hacker trying to break into somebody else's account, right? But to any legitimate user of a banking app, signing in is a hassle. If they can avoid doing that, they would just not do it, right? If your phone is capable of DNA sampling, people would just spit at the phone to authenticate and say, I don't want to enter my password. Are you kidding me? Just spit at the screen and sign in. And unfortunately, that technology is not available yet, but it's coming. So that's why sign in is not a use case, okay? Cashing a check is, Checking a bank account balance is, transferring money is, but signing in is not. Okay. What about security and privacy? Okay. In other words, people say, "Oh, I need to make sure this app is secure and my privacy is preserved and stuff like that." How does that fit in the value of the app and also in the use cases of the app? Well, the answer is it has nothing to do with those things. These are just basic requirements. Okay, so the security and privacy of an app is kind of like the security guards at an actual bank branch. Okay, does anyone go to a branch of a bank just to talk to the security guard? Well, if not, it is not a value of the bank. Okay, it's a necessary thing the bank needs to have for legal reasons, for the protection of its own properties and profit and whatnot, but it's not core to the reason why people go to the bank. Now, the bank has its own reason to have security cameras, security guards, and all kinds of stuff, but those things are mostly from the perspective of the bank itself, not from the perspective of the customers. So up to this point, in terms of value, in terms of use cases, they are all from the perspective of the end users. Okay? Not from the perspective of the developers, from the perspective of the end users. Are we doing okay so far? Well, that's a, yeah, go ahead.
So as a user, I want my money to be safe. How the bank does it is really their business. Is that what you're...
That's correct. Okay, but that's not it's not a value. It's not the reason why you go to a bank. It's just that when you do go to a bank, you don't want to be robbed.
Oh, okay. Okay.
Yep.
So, take an app for example. You could list those kinds of things as features, and they may entice somebody to use your app over somebody else's.
Correct.
If they have those things, but
Right.
the core reason is not.
That is correct.
that.
In other words, you don't walk into a bank just to feel safe. You want to feel safe while you are cashing a check, while you are getting cash, while you are getting a cashier's check. So it's kind of it's something that tags on to something else that you're doing, because you don't just walk into a bank to feel secure. Well, sometimes I do. Like when I have any type of a Craigslist transaction, I always go to the parking lot of a bank because it has closed circuit cameras, everything's getting recorded, security guards are close by, they don't know who's customer, who's not a customer. So, I just feel safer, if I have to sell anything through Craigslist. I always say, okay, let's go to Wells Fargo Bank, its parking lot, and park here to make sure I'm in the view of the camera. So sometimes I contradict myself because I do go to a bank just to feel more secure. All right, so getting back to games again, okay? So games are interesting also when it comes to use cases, because in most cases there's only one use of a game, to play, right? So, so in that case, you also have to look at the other values of a game, because there's also social networking in a game. Most games now have some form of social aspect to it. So, and as a result, chat can be a use case of a game. In other words, someone can start a game app just to chat. Okay? Do you guys think that's possible?
Yeah.
Yeah, my kids do it all the time. I go like, hey, why are you on the game? Because I need to ask someone for homework stuff. Well, I can see the screen is not inside the playing part of the game. It's just on the chatting side of the game. But that's how they communicate. They just go like, okay, let's hang out with this game engine, and they just use it as a social media stuff thing.
Like a chat room.
Like a chat room, exactly.
A lot of the game clients have apps that you can download if you just want to chat on the game client's app too.
Yep. Yep. The reason why people do that instead of deferring to texting and the more conventional thing is because they don't. It's the convenience. Okay, I already know that person plays the same game as I do, and they sign in at about the same time. I don't want to spend the extra time to find out, what is their phone number or some other way of communicating with those people. I already have a way to communicate. I'm just going to stick with that. So are we doing okay so far with the concept of a use case? Okay, from the perspective of the end user, what are the uses of this application? Okay, it's not a feature. Okay, a use case is not a feature. And just remember what is and what is not, using the examples. So that will help you understand what to consider as a use case and what to not consider as a use case. Okay, so with that done, go ahead.
Yeah, some applications may have multiple use cases, right?
Oh, most apps have multiple use cases. In other words, people would install the app for a variety of reasons, values, okay? And then even for one single value, they may have multiple uses. For instance, with a banking app, I might just click start my banking app just to cash a check without checking the balance or doing anything else. That makes it a use case. I may sign into a banking app just to check my balance. Okay, I just want to see how much money is my paycheck already automatically deposited. Okay, that makes it a use case. Now, on the other hand, if you do anything that by itself is not something that you would do, it has to be tagged with something else, that makes it not a use case. Okay. So signing in is not a use case because you won't sign in just for the sake of signing in. You're signing in to do something else. Is that okay? Does everybody understand what makes it not a use case? If you have to do something with an app because it is required to get something else done, and it doesn't serve any purpose or it doesn't have any value by itself, then it is not a use case. Okay. All right. So with that, we're going to move into use case diagram. And I think I got these two slides flipped in terms of order. So I'm going to talk about use case diagrams first. A use case diagram is basically, it's a way to document use cases. And remember, a use case is tied into at least one of the values of a particular app. So what I want to do is to give you an example, and it's very unlikely that any one of you will use this as your idea for your own app. So I think I'm safe there. All right. I just went to a field target match yesterday. So I'm going to use that as an example. I always use that as an example, but every year I get newer ideas and stuff like that. So first of all, let me describe what is a field target match. Okay. Does anyone know what is a field target match in this class? Okay.
Is it a shooting?
Yep,
target,
it's usually air gun. Okay, so field target match. And I'll just show you a picture. This is actually a pretty representative picture. We'll just look at the image itself. Okay, so despite what the rifle looks like a pretty big rifle, it's an air rifle. Okay, it's basically good for punching paper and also knocking over what we call field targets. So, and I'll show you what is a field target, just so that we have the context. Field target. I think we will be able to find some examples. There we go. This is what we kill in a match in field target. It's basically a mechanism. This is called a faceplate. The overall shape of a squirrel is called a faceplate. It's made out of steel. Okay, and there's a hole that we call a kill zone, and then behind the hole is a paddle. So the pellet would actually hit the paddle. If the pellet hits the paddle would fall over, and then the entire faceplate will fall over as well. Now you see a spool of string here, because these are usually placed from 10 to 55 yards. And when the shooter knocks down the target, then they use the string, they pull on the string and it resets the target. So they'll be ready to shoot at it again, or the next shooter can shoot at it again. Is that okay? So people keep score with these matches. They basically just shoot a variety of these things at different distances with different type of constraints, restrictions, and whatnot. Okay, in terms of equipment, in terms of technique and stuff. And they keep score, and that's about the nature of the game. Okay, if I need to summarize the nature of that match, this is what it is. Okay. So with this type of thing, you go like, okay, but how does that relate to an app? Well, guess how we keep scores. I'll give you a picture of a scorecard. Okay, so you look at the field, target, score card, and there are plenty of images here. Let me just see. I'll try to find one that is representative. Okay, this is actually pretty. Oh, this is good. I like this. Nope, that's not it.
View image.
Yeah, I'm already in image.
Yeah. It's gonna pull up the page.
But I want to find one that is kind of. Oh, this is a good one, I think. I'm just looking at the. Nope, that's not. I think that's a good one. This is a good one. Okay, so this is what we do in the match. You know, we get a clipboard with a piece of paper, and then on the piece of paper, we have the concept of lanes. Okay, so one lane can have multiple targets, and on each target, which in this case is labeled left, mid, and right, on each target, you know, typically you have 2 tries on the target. So if it is a hit, if the faceplate falls over, it's an X. If it's a miss, it is a circle. Okay, so you just keep these paperwork throughout the entire match. Okay, then you might say, okay, fine, but what does it have anything to do with apps? I don't want a piece of paper. Okay, there are several reasons. One, when you are going to these matches, your hands are full with equipment already, because you have to bring a bipod, a little stool, and also the gun and the ammunition and stuff like that. So you're carrying a lot of stuff already, and then you have to carry that extra clipboard, with it. And then you have to keep your pen and pencil, to keep the scores. Okay, and the other thing is, most of the time it's windy, and if your scorecard flies away, especially in the direction of the range, then you have to call code range, and then all the other competitors will say, "What? I was just about to shoot, blah, 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 blah." They will just keep whining until the end of the whole match. So this is archaic. And also, the worst part of this, from my perspective, is I have to add all the crosses at the end of the game. It's like, okay, let's count, the number of hits of this game. And then you have to turn in the paper, and then the match director will have to manually double check all the numbers, sort the cards in a particular order so they can identify who won the match on that day based on each division. So there's a lot of manual work, and you never know who else, who's doing what. Okay, let's look at John over there. John is a really competitive player. I want to know how he's doing today at this point of the game. Unless you walk over, you would not know. So I want to use an app to do all this stuff here. So what is the value of that app? How would you describe the value of an app that can just get rid of all the paperwork? Yep.
Simplify scorekeeping for field target goals and make it more convenient.
Exactly. Make it more convenient and make it more efficient and more accurate as well, because I'm not the one who's counting and adding up all the crosses. The computer can do that a lot faster with accuracy, right? Mm-hmm. Okay, so that's the value. Very good. What about the use cases? What is a particular use case of this app?
Someone keeps score, their own score.
Keep score. Okay, very good.
Keep score, yeah.
Yep, exactly. Keep score is a use case. Now, once it is computerized, okay, what about some other use cases that you can think of that would be kind of really, really hard to do with paper?
The winner could be determined quickly or
Okay, determine winner is a use case, but that's only for the match director.
Right.
Okay, so now we can start to say, oh wait, so how? Yeah, go ahead.
You can do statistics. You can say like, oh, you got 70% of your left lane things, but you only got 10% of your right. And you can have other kind of.
So you can say
things.
summarize or analyze results.
Yeah.
Okay, very good.
Keep track of match history.
Oh yeah, I like that. Now tracking by itself is not a use case because nobody's going to install the app just to track. The reason why you're tracking is because you want to retrieve. So you want to view or review scores from past matches. Now that's a reason to install the app. I would like to do that because I want to compare what I'm doing in this game with the previous match. Yep.
Communicate with friends during the match.
Okay, yep, compare or communicate, social, yep, socialize, yep.
To see how you rank at each step of the competition.
Okay,
Among your,
get ranking in real time,
Yeah.
okay, that's a use case. Now, with all those examples, did you realize that every single use case starts with a verb? Get real-time ranking starts with a verb. Retrieve historical record starts with the verb. Analyze result starts with the verb. Keep score starts with the verb. Okay, so a use case has to start with a verb because it's an action. It's a way to use the app. Is that okay? Okay, so let's say somebody says, oh, I don't want anyone to mess with my scorecard. I want an ability to lock out this particular app, until I enter a password. Okay, so the entering of a password, is that a use case? It's not a use case because nobody's going to install this app just so that they can enter a password, right? Very good. So I think you guys are getting the idea. How about setting up the scorecard? Like in this case, someone can enter the name, the starting lane, and also indicating which division they want to be in. Would that be a use case? It's not, because nobody's going to do that just for the sake of entering the name and the division and stuff like that and do nothing else. That's really just a necessary part of keeping score. And a necessary step to do something else is not a use case. A use case has to be able to stand on its own and say, yes, somebody can start this app just to do this. Are we doing okay so far with those concepts? Okay. Now, this is also an interesting app from the perspective of use cases because it has got two types of end users. We have the usual participant in a match, okay, so that you can enter, okay, I got a hit here, I got a miss here, and so on. And then you have a match director, who's the guy responsible to get all the information from everybody and come up with a ranking for that particular game. So each classification of users is called an actor. Okay, I know it's kind of weird, but it's called an actor. Okay, so in this case we have two actors because each actor is not a individual user; it is a classification of users. So in this case we have two actors. The first one being a field target match participant, and the second one being the match director. Is that okay?
What about someone just viewing it to see the results?
If you want to open up the app so that that's a part of what it does, then you can also have a third actor, which is a bystander or observer, if you will.
So an actor is a role?
Yes, an actor is basically a role, and then certain use cases apply only to certain actors. In other words, in this case, summarizing the ranking at the end of the match is a use case only the match director would do. Entering a score is not something that the match director will do, nor will observers do that. So only participants will be entering scores. But observing the progress of the game is something that an observer can do, but a participant can do that as well. And also, obviously, the match director can also do that. So there are use cases and there are actors, and how they relate is up to the application. Okay, there's no particular set pattern of how those things relate. Okay. So that's good. Okay, so we are moving ahead with the concept of use case diagrams. So a use case diagram, as the name implies, are diagrams that document use cases of applications. And in this case, you can look up lots of resources online. So you can look up use case diagrams and look under images, and there are tons of these. Now, some of these are actually incorrect because a lot of these use cases should not be use cases. Okay, people do not understand that the use case has to be able to stand on its own and be of value. Okay, so some of these are not good examples. But what they do look like, I just want to show you what they look like in general, is like this. Oh, okay. It's like this. Actors. Okay, can you guys kind of imagine which ones are actors? The matchstick figures, right? And the use cases are the ellipses. Okay, the bubbles are use cases. Now yours doesn't have to look this complicated, okay? Because these arrows are kind of something that's out of the scope of this class. So you don't have to do arrows. Arrows basically say, it's saying a web customer is a superclass of a new customer. Or the other way to put it is a new customer is a web customer. Okay, it's an object-oriented programming class concepts. We don't have to do that. Okay, all you have to do is to list all your use cases, connect your use cases using non-directional lines with the actors. That's all you need to do for the next homework assignment. Are we doing okay so far with the use of a use case diagram? How to make one, what it looks like, that sort of thing.
So no arrows on our lines? Sorry.
No line, exactly, no arrows. Yep.
So like this is when you have more than one different type of consumer. But if you only had like one consumer, is it just?
Then it's okay. You can have one single actor, but it doesn't make any sense to have an app that has no actor because that means nobody's using it.
In that case, would it just be like you take all of the circles and you just draw to that one actor?
Yep.
Okay.
Yep. Yeah, there are many apps like that. Okay. So then the next question is, how are you going to do this? Okay. I don't want any picture of napkins with ketchup as ink. Okay. So what we're going to do is to use a program called Omelette. Not omelet. It's omelette. Omelette. UMLT. Okay. So now you guys may be asking, okay, Tack, is this something that you invent and you just want us to do this? No, not really. Okay, UML, or the Unified Modeling Language, is really big. Okay, this is how people do documentation in industry for information systems. Okay, so this is a particular program that allows you to do this relatively quickly. And here's a hyperlink. You can just follow the hyperlink to the website where you can download it. It's a program written in Java, which means it's cool because you can run it on any platform. If you have Windows, it will work. If you have Linux, it's going to work. If you have Mac OS 10, it's going to work. No problem. And it has own tutorial as well. If you want to go through a tutorial of how to use the program itself, they have a tutorial as well. And this is the download link. Just find your operating system. Now we only need the standalone version because we are not using Eclipse in this class. So just go ahead and download the standalone version. And it's a Java program, so it's a zip file. So when you get it, just go ahead and unzip it. And inside there should be a jar file, JAR file. In most cases, you can double click the jar file and start it. Okay. Are we okay with getting this tool? Okay.
Our use diagram, does that have to be like on our final project, or can it be for anything right now?
It's going to be needed for your next homework assignment, because this homework assignment, which is project proposal, since I did not have enough time to talk about the project proposal itself, I'm not going to assign it today. So I will assign it on Wednesday, then you have a week to finish it. Okay, but you should probably read ahead of time a little bit, because I have talked about everything that you need to do the homework. It's just that I have not described the homework itself. You have to identify the values, you have to identify the use cases, and document the whole thing using a use case diagram with this homework. In other words, this lecture, this entire lecture, is the preparation for this particular homework. But this homework, in return, is helping you to get your project done. It's just a documentation process so that you can record what you think are the purposes and objectives of your application, what are the ways that an end user can use the application, and a diagram to document.
It could be a fictitious project then.
It can be. I'm not going to hold it, I'm not going to hold you accountable and say you have to do what you said you would do, but I would suggest, everybody to be realistic and use this as an opportunity to think about your final project.
Okay.
There was another hand.
That answered my question.
Okay.
Yeah, my main thing was if I put some use cases on there that I can't accomplish it within the app, is I don't want to be held at like, no, you said you're going to do this.
No. Well, I would much rather have people to overshoot a little bit at this point, because when I grade this, I'm not just going to count, is there a diagram? Check. Is there a description of the value? Check. Okay, I'm actually going to read it in the context of this class with App Inventor. If I see something that is, well, that may be a little hard to do, like image processing and kind of really high-end stuff that cannot be done in App Inventor, I'll just come back with the feedback and say, well, you might want to change this because this is really hard to do in App Inventor. So this is a way for me to see what you are planning to do, so I can give you some feedback as a result. So it's an assignment, but it's also a way for me to communicate with you and get an idea of what you want to do. Bob is here, hurrying the class to get out. So we are going to stop the lecture at this point. When we go to the lab, I'm going to show you guys how to use Omelet. Okay? Yep. Say it again.
You have a 10-minute break, yeah.